Welcome to the Math 1 lesson summary video for the task, Do You Have the Power? So this is a develop understanding task, and its purpose is to develop general methods for expressing equivalent forms of exponential products, quotient, and powers, commonly referred to as exponent rules, which you may be familiar with or should be familiar with from your 8th grade math course. So for example, we have a product here in problem 4, 2 to the 4th power times 2 squared. So we know that 2 to the 4th power means 2 multiplied by itself 4 times. 2 squared means 2 times itself. So combining that all together, our most simplified form would be 2 to the 6th power. So if I apply that same logic to the second row, 3 to the 5th power is 3 multiplied by itself 5 times. And 3 squared is 3 multiplied by itself twice. So altogether, I have 3 multiplied by itself 7 times in that scenario. Similarly, on the next row, I can see that I have negative 4 times itself 3 times in the first parentheses, and negative 4 times itself 3 times in the second parentheses. So we'd be looking at negative 4 to the 6th power. And then on the last row, there's a bunch of different ways you could do it. You could split it up as 5 to the 5th times 5 to the 7th, or any other variety that you want to. But I'm going to skip the middle part this time because I don't feel like writing out 5 12 times. But what you should notice is that there's a relationship between these two numbers and this number in the exponent. And so that relationship can give us an exponent rule. So if I have a to the x times a to the y, well, let's look back and see how did those exponents compare every time. Well, 5 plus 7 on the bottom row is 12, 3 plus 3 is 6, 5 plus 2 is 7, and 4 plus 2 is 6. So a general way of writing this would be a to the x plus y. Now it's not some kind of magical formula, it's just a faster way of representing all this repeated multiplication that we did here. So if I have repeated multiplication of 3 5 times times repeated multiplication of 3 2 times, total that's 7 repeated multiplications of 3. So that's why we're adding the exponents. And so that is one of the exponent rules, commonly called the product rule. So number 5, we want to look at quotients now and see what we can figure out. So 2 to the 5th power will be 2 multiplied by itself 5 times. 2 to the 3rd power would be 2 multiplied by itself 3 times. And so these can divide to become 1. Anything divided by itself is 1, so I'm left with just 2 to the 2nd power. Similarly, in the second problem, that's 7 times itself 6 times on top, and 7 times itself 3 times on the bottom. So these can divide to become 1, leaving us with 7 times itself 3 times. And then the last one I could do in a variety of different ways. I'm just going to do 8 times 8 times 8 times 8 times 8 times 8, 6 times divided by 8. So that would be 8 to the 6th divided by 8 to the 1st if I want to represent it. And so we want to see what kind of pattern is happening this time that can take us from exponents of 5 and 3 down to 2, 6 and 3 down to 3, 6 and 1 down to 5. And so we can see that that's subtraction, because when we divide to become 1 or cancel out, as people commonly refer to it, we are removing or subtracting some of the repeated multiplications of 8. So that's why it simplifies to subtraction. So we get what's called the quotient rule. So that is a to the x divided by a to the y equals a to the x minus y. All right, on number 6, this is a quick stop. If you type all these in your calculator, you will get 1. So that creates another rule for us for exponents, which is that anything to the 0 power is 1. So it doesn't matter what a is. If I raise something to the 0 power, I get 1. And now from that, we can find out what happens with negative exponents. So since anything to the 0 power is 1, I could take 1 over c to the n here. I could rewrite the numerator 1 as c to the 0 and leave the denominator as c to the n. And so let's call this the zero exponent rule. All we'd be doing here in step 1 is using the zero exponent rule. And then from there, we could rewrite this as c to the 0 minus n. That's using the quotient rule that we just established above. And then finally, we're just doing some 0 minus n is negative n. We're just doing some basic math, basic subtraction. But what we get is that 1 over c to the n is equivalent to c to the negative n power. So when I have a negative exponent, I can move it to the denominator and make it positive, or I take the reciprocal of it and it becomes positive. So for example, if I have 2 to the negative third power, then I could write that as 1 over 2 to the third power. If I have 5 to the negative second power, let's use a variable. If I had x to the negative second power, I could write it as 1 over x squared. Alternatively, it works the other way. If I had 1 over x to the negative fifth, then that could become x to the fifth over 1. So negative exponents are reciprocated, moved from numerator to denominator or denominator to numerator, and they become positive. To give this a name, this could be called the negative exponent rule. And finally, what do we do when we mix up all these things? We have powers of a product and quotient. So 2x in parentheses to the fourth power really just means 2x times 2x times 2x. So what you notice is 2 times 2 times 2 times 2 is 16. X times x times x times x is x to the fourth. On this next one, x squared y to the fifth raised to the third power, there's a typo there that was missing, becomes x squared y to the fifth times x squared y to the fifth times x squared y to the fifth. So then when I look at all my x squareds multiplied together using the product rule, I get x to the sixth. And then all my y to the fifths multiplied together, I get y to the 15th. Similarly, if I take the next expression, x to the fifth over y to the third raised to the fourth power, means I'm just multiplying by itself 4 times. And so we'll get x to the 20th over y to the 12th. And finally, at the bottom here, if we use our negative exponent rule, we can rewrite this as y to the fifth over 3 to the third power, because negative exponents mean we reciprocate. And so now I would have y to the fifth over 3 multiplied by itself 3 times, leaving me with y to the 15th over 3 to the third power, which is also 27. So in general, if I have a to the x and b to the y raised to the n power, what you'll notice is, so right here, 2 times 3 is 6, and 5 times 3 is 15. So this is equivalent to multiplying the exponents. We have a to the nx and b to the ny. The same works for division. If I have a to the x over b to the y raised to the n power, then that can become a to the nx over b to the ny. And so that's everything we really need to know about exponents and the way that they work at this point.